This question is about gravitational field strength. The first thing to notice is that the graph does not give values of gravitational field strength. It gives gravitational field strength compared to Earth. So the value for Earth is 1 here. Now that's not the actual value. On Earth it's 10, but this is compared to Earth. So obviously Venus and Mercury and Mars are less, and Uranus, and Jupiter, Saturn and Neptune are more than on Earth. Part 1 asks you which of these statements is correct. So the thing to remember is that mass does not change depending on where you are in the universe. So mass will remain constant whether you're on Earth, the Moon, Mars, anywhere. Weight does change. So weight is the force of gravity pulling us towards the centre, and that will depend on the gravitational field strength. So when you're looking at these questions, you need to think about this graph. So a 1 kilogram mass would weigh more on Venus than on Neptune. So Venus has a relative gravitational field strength that is lower than on Neptune. So that statement's not true. It would actually weigh less on Venus than on Neptune. Comparing Earth and Uranus, 1 kilogram mass would be less than on Earth. So that statement is true. So that's your answer. But just check the other ones, just to be sure. So a 1 kilogram mass would weigh more on Mercury than on Saturn. That's not true because Mercury has less gravitational field strength than Saturn. And 1 kilogram mass would weigh more on Mars than Jupiter. Again, not true because Mars has less gravitational field strength than Jupiter. On Earth, gravitational field strength is 10. You know that. You have to work out what it is on Mars by looking at this graph. So compared to Earth, if Earth is 1, Mars is only 0.4. Which means that on Earth, if it's 10, so 1 to 0.4 is what you got from the graph, which means that if your gravitational field strength is 10 on Earth, then it must be 4 on Mars. So the answer is C. This next question would no longer be on paper 1. It would only be on paper 2 for the specialist programme, but we can go through it here. It says calculate the orbital radius of Deimos for a satellite. So the equation that you use is you use speed, orbital speed, distance divided by time. But for an orbit, because it's a circular orbit, we assume, your distance is 2 pi r, which is the circumference of the circle, where r is the radius. And the reason we can do that is because we do it for 1 time period, so the time for 1 complete orbit, which is given there. Now it wants your orbital radius in meters, which means that you've got to make your speed here, which is in meters per second, and your time match. Now, at the moment they don't because your time is in minutes. So this is why it's a 4 mark question, because you've got to do some rearranging and you've also got to do some conversion of units. So the first thing to do is turn that minutes into seconds by multiplying it by 60. So when you've done that, your time should be 109,200. You can do that there, or you can do it later on. If you rearrange the equation, I'm just going to let speed be v, so I'm feeling lazy, then r is going to be v times t divided by 2 pi. And now you can just put your numbers in. So v is 1350, time is 109,200 divided by 2 pi, and that should give you an answer of 235,000. Okay, pretty huge. This question is simpler. The diagram shows Deimos in orbit around Mars. Which arrow shows the direction of the force of gravity that Mars exerts on Deimos? So Mars will be pulling Deimos towards it, so your answer is A.